This demo shows you the process of monitoring an AWS SageMaker machine learning model with IBM's Watson OpenScale, which is a powerful tool for monitoring and providing trust and transparency and explanations of your model. We'll first go through the process of setting up an AWS SageMaker model briefly. We are performing our monitoring on a credit risk predictive algorithm in which the machine learning model will determine whether a creditor has a risk of default. We first collect our data and visualize it here. Access a S3 storage bucket on AWS using our credentials and place our training data there for safekeeping. We'll then create our logistic regression model using SageMaker's linear learner algorithm. Here we set our model parameters, train our job. We'll then deploy our model to the AWS cloud using the credentials we provided earlier. An important step after your model is created and deployed is to configure endpoints for scoring and to allow other clients to access that endpoint, either on the web or for batch jobs. This will make the SageMaker model accessible to Watson OpenScale. We perform our initial scoring of the model, and now we're ready to bind the SageMaker model with Watson OpenScale using some straightforward authenticated API calls. So now that we've created our Amazon SageMaker machine learning model for the credit predictive risk assessment, we need to set up our credentials for accessing IBM's cloud object storage and OpenScale. So you'll need your cloud API key, which you can get from the command line interface or in the security tab on the IBM cloud. We will connect to our cloud object storage using the resource CRN and the endpoint for that object storage. You'll need to create a bucket in your cloud object storage to store the training data. Next, we configure OpenScale using the authenticated credentials that we provided earlier. And initiate that OpenScale client using this authenticator and API client connection. The Watson OpenScale makes use of data marts to store payload data and feedback data. So we will check which data marts are available and create one with Postgres SQL and a defined schema for storing our payload data to monitor the Amazon SageMaker model. The most important step comes next, where we bind our SageMaker machine learning engine to OpenScale. We make use of our AWS credentials once again and check the set our machine learning service provider as the SageMaker. Now this step binds our data mart in Watson OpenScale to the SageMaker machine learning model. We can access the details of the scoring endpoint that we created in the previous notebook for our SageMaker machine learning. And using that scoring endpoint, find the details of the asset that we've just deployed to it. Next, we'll set up our thresholds and feature attributes for scoring and performing our fairness, quality, and drift monitoring. So we'll set the metrics for which first to determine quality as the AUC, or area under the ROC curve, with a threshold of 80%. We'll send feedback records to evaluate the model to OpenScale. And we'll similarly set up the fairness and drift monitoring. For example, in the fairness monitoring, we use the female gender as the monitored gender, and bracket for age as a data group as being monitored, and which is our favorable and unfavorable class. For drift monitoring, we'll also set up a threshold and enable explainability. And now we're ready to view this deployment on Watson OpenScale and use its powerful features to perform monitoring throughout pre-deployment and post-deployment. You can see the fairness, quality, and drift monitors are set up and configured according to the steps that we took in the notebook. Again, the area under the ROC curve is our quality metric, and we have assigned the female gender and a bracket of age to monitor for fairness. We can dig into these each separately. We see that actually this model is particularly fair for age and gender. We can dig into specific transactions for our payload data and understand the prediction and confidence interval for those transactions. Let's choose that. This is a prediction for which has a 62% confidence that the outcome would be a credit risk of default. We see the top 3 features that contribute to this prediction, and the feature that would contribute to the prediction being flipped or no risk. We can inspect further to run an analysis on the smallest changes in feature values that would result in a different outcome. This is a proprietary code with IBM Watson OpenScale. And we see that if there was an employment duration greater than 7 years, if it was changed to the opposing value, you would have a different outcome. Let's go back to the Insight dashboard and check out the quality. There are no alerts. You can see the confusion matrix. There were 24 true negatives and 10 true positives, and a small amount of false positives and false negatives. We can monitor the drift in data consistency and accuracy. For the payload data that our model has been tested against, there are drops in both that fall below the thresholds that we set earlier, and alerts have been triggered. Let's dig in to look further. We have one historical data point for our evaluation that we just performed, but if you perform evaluations over time, you can see how there are drops in accuracy and drift in data consistency change as changing conditions occur or you make changes to your model. So let's dig into the drift. Transactions that are responsible for drops in data consistency and accuracy may be viewed separately, or those responsible for both can also be isolated. These transactions that led to a drop in accuracy, there are 12, and they are binned based on the features that they have in common that influence the drift in statistics or accuracy of your model. This goes a long way in helping you figure out what features are influencing the drift and what you need to change in your model to improve it. So let's go back to our main dashboard and back into our model. So anticipating alerts, it's important that you set up OpenScale to send alerts to notify data scientists and operations personnel immediately when the model starts to degrade so that they may intervene and perform necessary modifications and improvements. You can turn the alerts on and enter their email address here and have them be alerted immediately. This will ensure that the model remains robust in changing conditions. OpenScale also facilitates easy downloading of reports as PDFs. A PDF report looks something like this, shows the evaluations for that day, what alerts and breaches that OpenScale has found, and more metrics on statistics and what caused these concerns with the model. So overall today, I've shown you some of the powerful features of OpenScale software package, which addresses the 5 pillars of trustworthy AI: fairness, explainability, transparency, robustness, and privacy. By helping to ensure fair outcomes across different populations and enabling complete tracing of all decisions and predictions, and alerting you to drift so that you can ensure that your model is robust in changing conditions. The 5 pillars of trustworthy AI have been addressed. I've shown you how OpenScale enables monitoring AI at scale, where it resides, whether it's on the IBM Cloud or AWS SageMaker or any other cloud-based ML service, and even on premises.